At this point, we are now ready to learn about two basic terms in statistics, namely population and sample. What is population in statistics? It is the set of all objects or individuals of interest at any point in time. So let's say we ask the question, what is the average age of a Truman State University student? Well, that question concerns all Truman State University students, and that will be the population of interest as far as answering that question is concerned. What if we're not able to access all Truman State University students at any point in time in order to have the exact average age? Well, we can settle for a sample. And so a sample is a fractional part of the population or a subset of the population that we are interested in studying, especially when it is impossible to study the entire population. So, to test how much we understand here, let's consider the following example, where to identify the population and the sample. So, for the first question, we're told that in a survey, 100 college students at ABC College were asked how much money they spent on school supplies each year, excluding books. 3 of them answered $150, $200, and $225. Our goal is to identify the population and the sample. In this case, the population would be all college students at ABC College, and the sample would be the 100 college students at this same college that were surveyed. So right here on the screen, you can see the answer to question 1. We move on to question 2. In this case, there has been a survey of 1,125 households in the United States that were found, and we found that 19% listen to satellite radio. Again, we're to identify the population and the sample. The population here will be all households in the United States, and the sample will be the 1,125 households who were surveyed. So right here on your screen, you have the answer to question 2. We now proceed to other basic terms in statistics that we ought to learn, and that concerns parameter and a statistic. Notice that the use of the word statistic here is distinctly different from the broad area of study, namely statistics. So, what is a parameter and what is a statistic? In general, whenever we want to study a population, there is something about that population that we want to study. For instance, if we ask, what proportion of Truman State University students have an Instagram account? Well, the population will be all students at Truman State University, while the parameter or characteristic of that whole population that we want to study is the proportion of that population that have an Instagram account. So in this case, our parameter or our characteristic of the population is always a number that summarizes a property or characteristic of a population. Whereas, on the other hand, a statistic without the S is a number that summarizes a property or characteristic of the sample. In other words, we talk about population parameters or population characteristics in English, and we can also talk about sample statistic. An example of a population parameter is the population mean, the population standard deviation. Let's write this well. Population standard deviation and the population variance. We will talk more about this later. Then you have the sample mean, the sample standard deviation, and the sample variance. These are examples of sample statistics, whereas the population mean, the population standard deviation, and the population variance are examples of population parameter, since each of them is a characteristic of the population. So, to examine how well we understand this, let us carry on to the next example, in which case we will like to identify whether the highlighted value in each of these questions is a statistic or a parameter. Question 1. Following the 2014 national midterm elections, 18% of the governors of the 50 United States were female. You would note that this number pertains to the whole population of governors in the United States. So since it pertains to a whole population, it is a parameter. That is, this 18% is a parameter, a characteristic of the entire population of governors of the United States. Then question 2. Suppose that out of all students on your campus, a sample of 100 students is obtained. From this sample, we find that 46% own a car. This number pertains to information or a characteristic that typifies the sample. So this is definitely a statistic. Question 3. Only 12 men have walked on the moon. The average time these men spent on the moon was 43.92 hours. This is a number that pertains to the entire population of all those who have walked on the moon. So this is definitely a parameter. Question 4. One of the greatest baseball hitters of all time has a career batting average of 0.3666. Well, this number pertains to a whole population of all baseball hitters. And so it is a parameter or a characteristic of the entire population of baseball hitters. With that done, we proceed to the next page. We have another question here where we are told that a web designer for a retail store wishes to identify the average age of customers visiting the store's page. When people visit the store's page, they are invited to take a survey. 433 customers responded to the survey with an average of 29 years. In this context, or in the context of this problem, what is the population of interest? That will be all customers who are visiting the store's page. And what is the characteristic of the entire population? Or, in statistical terms, what is the parameter of interest? That would be the average age of all customers visiting the store's page. Then, the sample then, to be identified, would be the 433 customers who responded to the survey. Now we're required to identify the statistic that will be the characteristic of these 433 customers. We're told that 433 customers responded to the survey with an average of 29 years. So this number is a number that pertains to the sample and it is the statistic. So that will be the sample average age of 29 years. So we have written down the statistic, which is the sample average age of 29 years. And with that, we proceed to more basic terms in statistics. Here on the screen, you can see a table that takes an excerpt of a data that has been collected on purchase records from an online music retailer. This table is also called a data table. Now, since it's a data table, it's simply data, as the name suggests, or a table rather, that contains data. And so that brings us to the question, what are data? Data are the recorded actual values of the variables. The variables in this case that varies from one purchase to another are the order numbers, the name, the state or country, price, and so on. All column titles here are variables. And the values we are recording for each of these variables are your data. So that is why we say that data are the recorded actual values of the variable. Now, they may be numbers, as we can see in the case of price, or they may be just labels, as we can see in the case of album download, or even artist or name. Now, you see, when you ask journalists in the industry, newspaper journalists knows that whenever you're given a data, the context is always everything. And so we note that context is everything in data analysis. And in order to establish the context of the data, they ask questions pertaining to the 5 W's: who, what, when, where, and why. Sometimes we even ask how this data was collected, and that helps to add value to the process of using data to back business or organization decisions. So that brings us then to what the formal definition of variables are. A variable or variables are the characteristics of the individuals of the population being studied. Variables may be numerical, and otherwise they could also be categorical. So, what distinguishes a numerical variable from a categorical variable? Just to give quick examples or quick descriptions, more or less hand-waving descriptions to begin with, numerical or quantitative variables take on values with equal units, such as, let's say, the weight in pounds, and you observe that they are inherently numerical. You collect a person's weight, you're recording it in numbers that can be added, subtracted together. Then, on the other hand, we talk about categorical or qualitative variables, which place a person or a thing in the population into a group or a category. We're going to talk more about this. In order to guide our discussion on the differences between numerical or quantitative variables on one hand and categorical or qualitative variables on the other hand, we proceed to the next page. So far, we have identified quantitative or numerical variables away from qualitative variables. Quantitative variables are also called numerical variables, whereas qualitative are also called categorical variables. What makes one different from the other? We attempt that on formal grounds. You see, if you have a quantitative or numerical variable, they have to do with numerical measures or observations that are recorded as numbers of individual characteristics of population units. Now, they can either be discrete or they could be continuous in nature, depending on whether the numbers come from either a counting or measuring process, respectively. So, if you observe that you have to count to get the number, it will be a discrete numerical variable. If you have to measure in order to get the number, it will be a continuous quantitative or numerical variable. So, examples of numerical variables are the amount of money in your bank, or your bank, or your account balance. Let's put it that way. Your account balance. It could be the sale price of a house. It could be the pulse rate of one's heart. and it could be the number of people living in a town, etc. Take note that each of these variables are recorded as numbers when they are observed for each unit in the population of interest. Then, we talk about qualitative and or categorical variables. These are variables that allow for classification and or ranking of individuals in a population. So, to help us understand this, whenever we talk about qualitative or categorical variables, their measurements are inherently used for either grouping, just grouping or naming, or ranking. So, for example, a 5-star product on Amazon.com is not in the same league as a 3-star product on Amazon.com. So, there is a grouping there, 5-star products away from 3-star or 1-star products. And in a similar way, we can identify other examples. Examples are the credit status, either bad, poor, or good, of loan customers, and the marital status of customers. That can also be regarded as categorical variable. And other examples are hair color, blood type, ethnic group, the car a person drives, and possibly the zip code that you live in. These are all categorical variables that can place us in one group away from other groups. So, take note that it is possible to sometimes collect data as numbers and report it categorically. For example, the quiz score for each student are recorded throughout the term. At the end of the term, we convert that score, the numbers, into grades, A, B, C, D, E. So at the end of the day, it becomes what? A categorical variable. So let's test our knowledge. We would like to classify the following data as either qualitative or quantitative. For question 1, we talk about the number of pairs of shoes that you own. This will be quantitative since you need to count it. So this is a discrete quantitative variable. What about the type of car you drive? What do you think? I think this is categorical or qualitative. Then, where you go on vacation, that will be qualitative because it will categorize those who go to a particular location away from others. Then question 4, the distance from your home to the nearest grocery store, that would be quantitative because you'll be measuring it, and that makes it a continuous quantitative variable. Then the tuition for your classes, that is also quantitative. Do we count it or do we measure it? Actually, we measure the value, and so this is continuous quantitative variable. So with that question completed, we look at the next example. Here we have a table which we saw earlier, and in this table, which of the variables are quantitative, which are categorical? Take note that order number, name, state or country, area code, album download, gift, yes or no, stock ID, and artist, all of these are all categorical because either it places each purchase in its own group, in which case it's a unique identifier, or it places it in a group along with some other purchases away from all those who share different characteristics. So all of the circled ones on your screen are all categorical. So all column names except price. Price is the only quantitative or numerical variable here, which has been measured in terms of the value of the online music. So let's see another example. we're to write T if the statement is true and F if the statement is false. The first question says, a sample is selected from a population in cases where selecting data from the entire population is either very difficult or very expensive. This is definitely true because we use inferential statistics to select sample data, analyze the sample data, and see how well the deductions or inferences we make from the sample data can extend to the entire population. Then we have another question. A pharmaceutical company conducts a study where 50 patients are given a drug. They find that 10% of patients experience nausea as a side effect. This 10% is an example of a parameter. In the context presented here, apparently, the 50 patients are administered the drug as a sample of those who will be taking the drug. So this number, 10%, that pertains to this sample will definitely be a statistic, a characteristic of a sample, not a parameter. So the correct answer here is false. Question. Parameters are descriptive numerical measures, such as average, that describe the entire population. True, parameters always pertain to the entire population, so this is true. Then, next question. Statistics are measurements or measures computed from the entire population of data. Not true. Statistics pertain to a sample. That is, you compute sample characteristic, and that sample characteristic, such as the sample mean, is called a statistic. So this would be false. Now, it is very, very important to note the following. That is important to know the data type we're dealing with, and as well as what we call the level of measurement of the variable. The level of measurement of a variable will be discussed next after this discussion, and both characteristics of a variable are important before we decide what statistical method to use. In other words, it is important to know the data type and level of measurement of a variable on which data values are being collected, because the statistical method used to analyze a variable by itself or its relationship to other variables in a data set depends on it. With that said, it is now time to do another moment where we would focus more or zoom in on quantitative variables. So as far as data is concerned, we collect variables in data, and that variable can either be quantitative or numerical or qualitative. As we said earlier, we're going to throw a special light on quantitative or numerical variables. These can either be discrete, which comes from a counting operation, or continuous, which comes from a measuring operation. So you see, a discrete variable is a quantitative variable that has either a finite number of possible values or a countable number of possible values. The number of cars that stop at a road intersection in a 5-minute interval, for example, is a discrete variable. We can count it. So take note that the term countable means that the values result from counting, and so the only possible values of a discrete variable are all number values, 0, 1, 2, 3, and so on. A discrete variable cannot take on decimal numbers. On the other hand, a continuous variable is a quantitative variable that has an infinite number of possible values that you obtain after a counting operation has been carried out, after a measuring operation has been carried out rather. You see, the punchline we want to emphasize here is that if you count to get the value of a quantitative variable, it is definitely discrete. And otherwise, if you measure to get the value of a quantitative variable, it is continuous. With that done, let's consider the next example, where we would like to determine whether each of the following data descriptions represent a continuous or a discrete variable. 1. The number of classes you take in a semester. You will need to count, and that makes it a discrete quantitative variable. What about 2? The weights of sumo wrestlers. We will need to measure this, so that makes it a continuous quantitative variable. Then 3, you have the distance you drive to school. We do measure that using a speedometer, and that makes it a continuous random variable. And then 4, the number of heads obtained after flipping a coin 5 times. Well, that will need to be counted, and so that makes it a discrete quantitative variable.